standard of Unit 4 deals with transformations, and it's going to be a reminder of transformations. It's going to remind you of what we did in Unit 3. The only difference is now we are doing with exponential transformations. The parent function, or most basic function for the family of exponential functions, is f of x equals b to the x power, where the base b is greater than 0. All exponential functions can be thought of as transformations of this parent function. Unlike what we did in the last unit where y or f of x equals x squared, that was in the normal. When we're dealing with exponential, it's b to the power of x, where b is greater than 0. Constants. When you add a constant to the output, it results in a vertical translation. Okay, remember translation, the shape, the size of the function does not change. It is just being slid. The graph of g of x equals f of x plus k moves the parent function k units up. If k is positive, moves k is positive of k units down if k is negative. So if the k is positive, it goes up. If k is negative, it goes down. The function g of x equals 4 to the power of x plus 3 adds 3 outside the parent function for the power of x, and therefore moves the graph 4 units up. Okay? That should feel similar from Unit 3. Okay? Same concept. Adding a constant to the input results in a horizontal translation. Remember, if it's inside a parenthesis, it moves left or right. For example, h of x equals 4 to the power of x plus 3 adds inside the parent function and therefore moves the graph 3 units to the left. Remember, if you add, you go left, subtract, go right. And then there's the example. Here is 4 to the power of x plus 3. As you can tell, it moved up. And then here's the parent function, 4 to the power of x. And then the 4 parentheses x plus 3, it moved to the left. Reflections. Okay, remember what a reflection is. It's a mirror image of that shape. Another way to transform an exponential function is by reflection. Changing the sign of the output as the g of x equals negative f of x reflects its graph over the x-axis. Changing the sign of the input, as in h of x equals f of negative x, reflects over the y-axis. Okay, an easier way to remember that. You give a negative to the base, it reflects over the x-axis. You give a negative to the exponent, it reflects over the y-axis. And here are your rules. Follow these and you'll be good to go.